13.5 is applying the law of sines, and you probably talked about it in geometry, and it is applicable to solving any triangle, not just right triangles, so it comes in very handy. The law of sines simply says it can be used to solve triangles when you know two angles and the length of any side. So going back to geometry, of course, if you have an angle side situation or an angle side angle, those are cases when you can use the law of sines. The other case is side-side angle, and I would just highlight this case. It's called the ambiguous case because it's unknown initially until you look into the triangle as to if you could have one triangle or two triangles or possibly no triangles. So looking down here, you see the first triangle, you know an angle and a side and an angle. I'm just making sure you remember this from geometry. The second triangle is an angle, and a side. And the last is a side, angle. And I just remember this last one, if it's, the bad word spelled backwards, and that's the ambiguous case, and I'll talk more about that. But first, the law of sines is set up as the proportion of a pair of sides and the sine of the angle opposite to that side. So very, very easy formula to use. So as long as you know a side and its angle opposite and then any other side or angle, you should be able to solve for missing pieces in that triangle. So for example, if I knew side B, and let's say I knew angle B and then side A, I could go over here. Well, I would know side B and angle B, so I'd know all of this, and I would know side A. So if I know this and this, I can easily solve for angle A. Well then, of course, once you know angle A, you already knew angle B, you could find angle C because you know a triangle adds up to 180. And then you can set up another ratio to figure out side C once you know angle C. So it's very easy. Remember, you can cross multiply when you have a fraction equals a fraction. And these can be flipped. If you flip and put the angle on top and the side on the bottom, that's totally fine as long as you're consistent with your flipping throughout, of course. Alright, I'm not actually going to full out solve a triangle using law of sines because there are other videos that do so, but I want you to understand how the side-side angle case works. So this triangle here, note that you have an angle A, an angle B, and side A. So if I just set up those trig ratios, if I say side A over sine of angle A equals side B over sine of angle B, and then of course I could cross multiply to solve for B, and I'll just kind of show that setup. You'd want to make sure your calculator is in degrees, obviously, and from there I could divide both sides by the sine of 28 degrees to get side B, and I would obviously dump this in my calculator to get B, and I'll do that in a second here. So B equals 16.7. And then, of course, you could set this up again, and like I said, I'm not going to finish this one because there are other videos to watch, but once you know side B, you could set up a different trig ratio to find side C. You also knew two angles, so you know that the third angle, of course, because this is a triangle, has to add up to 180. So that third angle, C, has to be 50 degrees. Now, I want to talk about one thing here. Because this was the case where you have two angles, you're only able to have one triangle. So I want you to think about it because it's very logical. If you have two angles, that third angle definitely can only be one measure to make 180. So there's only one way to arrange a triangle. Okay, now I want you to think about what if you had the ambiguous case, which is side-to-side angle. Okay, so now maybe I give you an angle and two sides, and let's say I said side A is 5, side B is 10, and angle A is, 37 degrees. Well, angle B and angle C could be different things depending on these lengths. For example, it could be that these lengths and this angle cannot make a triangle at all. So the possibility is you might not have a triangle at all. And there's a video on Moodle that talks through the no triangle case. Another possibility, of course, is that this angle and these two sides create just one triangle. But the last possibility, which is the most work, of course, is this angle, this acute angle, and these two sides might actually form two different triangles depending on what angle B and angle C are. So that is why the side-side angle case is called the ambiguous case, because it's it's ambiguous. You have three possibilities in terms of answers. So make sure that you watch each of the videos. There's one of each of these, and you'll see how you determine that.